Good morning, everyone. And thank you very much, Bob, and thank you very much for a kind invitation to the Ocean 2010 as a plenary speaker. My name is Yoshio Isozaki, Director General of Marine Technology Center of Jamstack. At first, I have to apologize that according to the original program, Dr. Tyler was scheduled to have a plenary session, plenary speech, but suddenly he has become impossible to attend this conference. So I make a presentation in place of him. Today, I will have a presentation titled with Drilling the Deep Earth and Deploying the Earthquake Monitoring System. In this presentation, I introduce the activity of our world's largest and most advanced scientific drilling vessel, Chikyu, and the sea bottom real-time monitoring system to reduce the disaster by mega earthquake. This photo shows the drill ship Chikyu. Chikyu in Japanese means the earth. Okay? At first, I would like to introduce our Jamstack briefly. Jamstack is a comprehensive Marine Earth Science and Technology Institute. Through its research and development activity, Jamstack is attempting to clarify the Earth's ocean and center ecosystems. To fulfill these roles, Jamstack undertake research and development in 4 important areas. One is research on global change, and one is research on Earth evolution. One is research on biogeoscience. To achieve such a science research activity, we are carrying out the fundamental technology development, fundamental ocean-related technology and development we are carrying out. Jamstack is organized with 3 sectors. One is a research sector, second is a development and promotion sector, and management sector. In total, 1,100 employees are working for Jamstack. One of the features of Jamstack is owning and operating research vessels, 8 research vessels. In addition to that, we have several manned, unmanned underwater vehicles. This photo shows the 8 vessels under operation. A small one is this. Tansei Mao is the smallest one. The Mira is the larger one. And today, I introduce Chikyu is the largest research vessel in Jamstack. Also, our facility has world-class technology capabilities. Under AUV, Urashima has a record cruising distance of more than 300 kilometers. Also, Shinkai 6500, it's a manned underwater vehicle. It's experienced more than 1,000 dive. Also, we have an Earth simulator. It's a huge computer. It's also still used. Okay, well, I introduced the CQ. This is the outline of the CQ. It has been completed in 2005, following 5.5 years construction period. Overall length is 210 meters, breadth is 38 meters, gross tonnage is approximately 60,000. Total weight, total displacement is also 60,000. CQ is provided with the world's largest drilling derrick to drill into the deep earth. The height of this derrick is 130 meters from the bottom. It's a similar height to the Smith Tower in Seattle. This Smith Tower is 143 meters high. Okay? And now CQ is a capability to drill in the water up to 2,500 meters. And to drill down the 10,000 meters from the sea surface. But now we are improving this capability to reach the mantle. In future, we are planning to improve the capability. Water depth is 4,000 meters plus alpha, and drilling capability is 12,000 meters from the surface. Now CQ is operating in the Nankai Trough, of course, offshore, off west coast of Japan. CQ is provided with the laser drilling technology. This shows the laser pipe is provided between the vessel and the seawater, as sea floor. This and the drill fluid, we call the drilling mud, is circulated from the vessel through the drill pipe and go up to the sea vessel. Drill pipe, however, one drill pipe has a length of 9.5 meters and the diameter is 13 centimeters. To drill around 10,000 meters, we have to connect 1,000 drill pipe. This picture shows the bottom of the drill hole. The drill mud is circulated here through the drill pipe and returned to the outside of the drill pipe. To withstand this drilling mud, density and viscosity can be controlled. To withstand the pressure of this isosceles pressure, the heavy water column can withstand this pressure. Otherwise, this drilling hole collapses. In that case, we cannot continue the drilling more. Also, this viscous fluid can return the cuttings up to the surface. So, in the drilling hole can be kept clear. Otherwise, cuttings gather in the bottom and it is very difficult to continue the drilling. In the old scientific drilling system, riserless drilling systems are applied. Riserless means no riser pipe. No riser pipe. Just drill pipe is deployed from the vessel to the drill hole. In that case, drilling fluid flow out into the sea. So, in that case, as drilling fluid seawater is used. It is difficult to control the density and viscosity by the seawater. So seawater cannot withstand the pressure in the layer. So drilling depth is limited. Now, scientific drilling record under seafloor is around 2,000 meters. Chikyu will soon break such record. After the completion of in 2005, Chikyu has been involved in the various projects. Okay, first of Japan, and next of Kenya, and of Australia, and back to Japan, and now involved in the IODP project. Our record is water depth 2,200 meters, and drilling depth below the seafloor is 3,700 meters. It's a world-class record. Now, Chikyu is operating mainly at the Nankai Trough of Japan. I will explain in more detail later. The Chikyu drills the earth and recovers the core. Core is a cylindrical geological sample, usually 9.5 meters, and the diameter is 7 centimeters. The core sample leaves the various riddle on the earth. For example, sampling material from the upper mantle is clarified behavior of mantle. Also, we are now trying to the sampling directly from the seismogenic zone. Also, research for underground biosphere are our target. In addition to the, such research, the research on climate change is one of the main scientific purposes. As a result of another drill ship in Gulf of Mexico, the recovered core shows the possibility that the extinction of dinosaurs happened 65 million years ago was caused by the impact with the minor planet. Okay, the fossil of the foraminispheres is completely different between the before and after the impact. This is a boundary layer. Some melt glass ball is found in this boundary layer. It's a boundary. It's a Mesozoic era and Cenozoic era. Like this, the drilling the Earth will clarify the riddle on the past climate change and contribute to the prediction of future climate change. The Chikyu is now drilling in the Nankai Trough off southwest coast of Japan. Here, okay, it's a Japan island. The reason why the Nankai Trough is selected at the drilling site is due to this complicated plate boundary around Japan. Surrounding Japan, 4 continental ocean plates exist. This Nankai Trough, Philippine Sea Plate, is subducting Eurasian Plate with 4 centimeters per year. 4 centimeter per year is the growing speed of our nail. This shows the section of the Nankai Trough. This is a Philippine Sea plate is subducting into the Eurasian plate. This area, the seismogenic zone, we are trying to recover the core from this seismogenic zone. Okay. Now the project is called IODP, Neutral Sites Project. IODP is an integrated ocean drilling program. It's an international marine research drilling program dedicated to advanced scientific understanding of Earth by monitoring, sampling, and instrumenting subsea floor environment. IODP has operated since 2003, funded jointly by United States and Japan. Additional support is provided by 22 member countries. In total, 24 countries are participating. Already, we drilled several locations. Finally, we are now doing to reach the deep Earth around 6,000 or 700. This at this C002 area. Nankai Trough area is famous for the strong current named Kuroshigo. 2 years ago, we experienced very, very high current, more than 5.5 knots. Under such strong current, round pipe is vibrated perpendicularly to the streamline by the vortex caused behind the drill pipe. This phenomenon is well known as the VIV, Vortex Induced Vibration. I showed a video taken on the Chikyu 2 years ago. In this case, this is drill pipe, 13 centimeter diameter. Okay. Current is streamed from this direction, and pipe is vibrated perpendicular to the streamline. Okay, also another angle. The streamline here, and the pipe vibrated perpendicular to the streamline. Okay. In case it is a riserless drilling, drill pipe is vibrated. In case of riser drilling, riser pipe has a large diameter 1.2 meter. In that case, normal operation period, 3 months. During 3 months, such riser pipe will vibrated more than 1 million times. It causes a fatigue problem. In order to confront against the VIV problem, we have developed the riser fairing system. Riser fairing system, which fairs the streamline fair, which makes the streamline fair behind pipes, not cause the vortex. Then we have applied to the riser fairing system to the actual operation. This yellow color shows the fairing, riser fairing. This fairing can rotate around the riser pipe according to the stream direction. we gained a good result. This riser fairing is very effective. During the operation, we installed the riser measurement system, six-dimensional accelerometer. We installed the 6 sets, and we measured the performance of the riser pipe. It's a very rare case. Such measurement is very rare, and such obtained data are very variable. The main task of drilling is to recover the core, as I explained before. This photo shows the core recovered on board GQ. As I explained, this one core is 9.5 meter long and 7 centimeter diameter. Before cutting half of this core, the inside of core scanned by the CT scanner. This medical CT scanner. So this CT scanner is the same one provided in the hospital. It's the image by the CT scanner. You can see the normal fault is like this, and such slipped 2 layers. Okay. This photo shows the cut core into half. This pattern called vein, it shows the water course at the earthquake occurred in the past. Then I'll show the example of drilling dust at Nankai Trough. In the recovered core, the methane hydrate were found. As you may know, the methane hydrate called fire ice, like this fire ice, is a solid crystallate compound in which large amount of methane gas is trapped within a crystal structure of water, forming a solid similar ice, like this. They are expected as natural resources. This shows the recovered core, inside of the recovered core. The white area shows the contain much hydrate. Another example of the drilling result is the core of sediment and basement interface. This is cut half core. This reddish brown part and this green part is recovered as a one part. It is an interface here. Okay? This core recovered here is the starting point subducting. These rocks are considered to form the asperity. Asperity means the point where the large seismic slip occur and generate earthquake. After they are transported to the seismic zone, it's the original material of the seismic zone. Scientists call this core miracle core. It's very, very rare. Then I'll introduce the earthquake monitoring system. In Nankai Trough is very famous. Every 10, 100, or 200 years, magnitude 8+ class mega earthquake have occurred and they caused considerable damage in this Nankai area and the Tonankai and the Tokai area. This is a record of megatrust earthquakes in Nankai and the Tonankai area. Nankai and the Tonankai Tokai area. Recurrence time interval in the Nankai area is 180 years. In the Tokai and the Tonankai area, it's 176 years. The last big earthquake occurred in 74 years ago. So we are now endangered to the earthquakes within several decades. To prevent such disaster or to decrease damage, we are deploying the earthquake monitoring system. This is outline of the earthquake monitoring system. 2 observation stations is provided and 200-kilometer cable loop is connected to such observation station. Tomorrow, Dr. Kaneda of Jamstec will explain more detail in the session. If you are interested in this system, please join such session. We are planning to extend this system to the adjacent system, and in future, we wish to develop such more networks in the world. Okay? In this system, the several stations is provided on the seafloor, and during Nankai trough, we installed the sensor in the deep hole. We call it a long-term borehole monitoring system. After drilling in the deep hole, we installed the inclinometer, seismometer, and such information is sent to on land through the cable. If such abnormal activity in the deep layer is sent to the public even 1 minute earlier than the usual, at that time, traffic can be stopped and fire can be switched off. It's reduced the damage by the mega earthquake. Now, this shows that now we are trying to approach the mantle. This is the interior of the Earth, very thin crust and the mantle, and center, the core exist. It is said mantle is 80% volume of the Earth, and also continental plate and ocean plate moved according to the mantle convention. So also, recently it is said a huge volume of carbon dioxide exists in the mantle. To reach the mantle is solve the major riddle on the Earth. More than 40 years ago, correctly speaking, in July 1969, United States Apollo 11s brought back the stone from the moon. Moon is apart from the Earth by 380,000 kilometers. On the other hand, mankind never reached the mantle, mantle exists only 10 kilometers below our foot. Now, our middle-term target is to reach the mantle, recover the core by the GQ. Okay, as I explained, now scientific drilling record is 2,111 meters. To reach the mantle, we have to drill in the water more than 4,000 meters and 7,000 meters below the seafloor. It is much, much deeper than the existing record. In order to drill in the deep water down to the deep earth to reach the mantle and recover the core of better quality, we need some more improvement of GQ. Therefore, we are now developing a new technology as a Japanese national project. Okay. Deep drilling technology is necessary to drill deeper and vertically in the high temperature area. So also, ultra deep water technology is required to deeper water around more than 40,000 meters. Also, long-term borehole monitoring technology is needed to monitor the earthquake. Also, deep biosphere calibration technology are required. Okay. Through such improvement and effort, we are now approaching to the mankind never reached field, like Ichiro. Thank you for your attention.